Hello students, how are you doing? I want us to look at linear inequalities today, and I want to point out again the common mistakes that you guys make when doing linear inequalities. I want us to get started. I'm going to start by introducing you to the inequality symbols. Let's get started. What are the inequality symbols? We have got 4 inequality symbols. What are these 4 inequality symbols? The first one is this one, which we describe as greater than. This inequality symbol is described as greater than. Then we have the next inequality symbol, which is this other one. How do we describe that one? This inequality symbol is described as less than. We have got that inequality symbol, which stands for less than. Then we have got this other inequality symbol. What does it stand for? It is greater than or equal to. Then we have got the last inequality symbol. What does this one here stand for? It is less than or equal to. These are the 4 inequality symbols. Greater than, less than, greater than or equal to, then we have got less than or equal to. I want us to make the difference very clear between this inequality symbol and this inequality symbol. Where does the small difference come in? Let me start with this one here. And I want to give you an illustration to bring out the difference between the 2 inequalities. Between the 2 inequality symbols. Let me start with the first one. When we say that P is greater than 3, when we say that P is greater than 3, what does it really mean? When we say that P is greater than 3, it means the possible values of P, the possible values of P could be 4, the possible integral, I want to be specific, the possible integrals values of P could be 4, 5, 6, 7, allow me to skip some numbers, 23, 34, 7,000, etc. The numbers can be as many as you can list. But do take note, we start from the number 4. The first possible integral value of P to consider becomes 4. And whenever I talk about the word integral, I mean integer or whole number. So what are the possible values in the possible integral values of P? The values of P could be 4, 5, 6, 7, 23, 34, 7,000, 1 million. The list is endless. For as long as the numbers we are talking about is any number starting from 4 henceforth. But when we say that P is greater than or equal to 3, what does it really mean? It means that here the possible integral values of P could be the 3 itself, take note of that. Then we proceed to numbers like 4, 5, 8, 13, 20, 7,400, etc. Again, the list is endless. If you're keen enough, you should have noticed that for the first one, the 3 wasn't considered as one of the possible values of x. But for the second one, the very first possible value of P becomes the 3 itself. The question should be, why am I allowed to include the 3 here, but for this one here, we are not allowed to include the 3? Do remember, the inequality symbol itself mentioned that P is either greater than 3 or equal to the 3 itself. Which means here, the first possible value of P to consider is 3, while here, the 3 is not considered as one of the possible values of P. I hope that is understood. Which now takes us to the next thing. Rules of inequalities. Rules of inequalities. What are the rules that will be governing this topic? There are some 2 rules I want us to consider when doing inequalities. What are these 2 rules? One, when the elements of an inequality, are interchanged. When the elements of an equality are interchanged, the inequality symbol changes as well. A common mistake that students do. Please do take note, when the elements of an inequality are interchanged, the inequality symbol changes as well. What do I mean exactly? Allow me to consider this example, or I want to use this one here to illustrate it. I want us to consider the number 2 and the number 7. Which is the correct symbol to put between the 2 and 7? Do we say 2 is less than 7? Or do we say that 2 is greater than 7? Or do we say that 2 is equal to 7? Which of those 3 options would you consider to be correct? This is obviously wrong, because 2 will never be equal to 7. This is again automatically wrong, because 2 will never be greater than 7, which means the correct inequality symbol here should be 2 is less than 7. Now, what does the rule tell us? The rule states that when the elements of an inequality are interchanged, the inequality symbol should change as well. What do I mean exactly when I say when the elements of an inequality are interchanged? Interchanging means the 7 comes to take the place of 2, and the 2 moves to take the place of 7. That is what I mean by interchanging. Be reminded that if these two are interchanged, then there is no way this symbol will remain the same. The symbol should now become greater than. I would call it common sense, but then again, I want us to take it seriously because it's a common mistakes that students do. Either students forget or maybe they do not know that when the elements of an inequality are interchanged, the symbol should change as well. This is common sense. Why do I say it's common sense? It is automatically wrong to interchange these two, then retain the symbol the way it was. This is mathematically wrong because 7 cannot be less than 2. 7 should be greater than 2. I hope that rule is taken into account. This is supposed to mean that if you're confronted with another situation tomorrow, for example, t is greater than -7. Even though we don't know the value of t, what the student needs to know is that if these two things will be interchanged, so that the -7 moves in the place of t and the t moves in the place of -7, it should be understood that for this thing to remain mathematically true, then this symbol has to be changed so that it becomes less than. So if t is greater than -7, then -7 is expected to be less than t. And that brings us to our second rule of inequalities. What is our second rule of inequality? The second rule states that when an inequality is divided or multiplied by a negative. When an inequality is divided or multiplied by a negative, the inequality symbol should change. What exactly do we mean when we say that? Let's consider this example again. We have got negative, okay, let's consider the number 5 and -3. Let's consider the number 5 and -3. Which is the correct inequality symbol to put between the two numbers? Do we say that 5 is greater than -3? Or 5 is less than -3? Or 5 is equal to -3? Which of those three would you consider to be correct? This is automatically wrong because 5 will never be equal to -3. That will never happen. And 5 cannot be less than -3, which should mean that the correct inequality symbol should be greater than. So 5 should be greater than -3. I want you to take note again. When this inequality is divided by a negative or multiplied by a negative, the inequality symbol should change. I know you could be asking yourself, what would make me want to divide an inequality by a negative? You'll come to see when we get to solution of inequalities. For now, just bear in mind that anytime an inequality is divided by a negative, this symbol has to change. Let's consider this. We have already agreed that 5 should be greater than negative 3. 5 should be greater than negative 3. Let's divide both sides by negative 1. If both sides are divided by negative 1, what is 5 divided by negative 1? That should give us negative 5. And what is negative 3 divided by negative 1? That should give us a positive 3. Agree with me that retaining this symbol will result into a false inequality because negative 5 can never be greater than 3. Negative 5 instead should be less than negative 3. That is the reason as to why we are saying that when an inequality is divided by a negative, this symbol should change. And those are the two rules of inequalities that I want you to take into consideration. Which now takes us to the next phase. In our next phase, I want us to look at solutions of inequalities and number lines. How do you solve inequalities and how do you put the solution in a number line? First things first, when representing inequalities, in a number line, do take note, these two symbols will call for an empty dot. Allow me to use the word empty. While for these two other symbols, a student will be required to use a shaded dot. So for these two symbols, you will be required to use an empty dot, while for these other two symbols, a student will be required to use a shaded dot. I want us to consider examples of what I'm talking about. Solve the inequalities below. Solve the inequalities below and represent the solution. And represent the solution on a number line. And represent your solution on a number line. I want to consider 3 examples, and this will be our first example. 3 plus 2x is greater than or equal to 11. 3 plus 2x is greater than or equal to 11. 5 minus 3x is less than negative 4. 5 minus 3x is less than negative 4. And last but not least, 3x, 3 into bracket x minus 1 is greater than 4x plus 7. We are required to solve those inequalities and represent the solution on a number line. Let's get started. I will start with the first one. We have 3 plus 2x is greater than or equal to 11. 3 plus 2x is greater than or equal to 11. How do we solve this inequality? In order to solve this inequality, the normal rules of mathematics will not change. The normal rules of mathematics requires me to put like terms together. 11 and 3 are considered to be like terms. So the 3 will cross over to the other side of the inequality symbol so as to become a negative, because at the moment it is a positive. So I'll have 2x is greater than or equal to 11 minus 3. 2x will be greater than or equal to 11 minus 3 should give us 8. Divide this by 2 and this one here by 2. These two will cancel out. So x will be greater than or equal to positive 4. That is the solution of that inequality. So how will you represent this solution in a number line? In a number line, I will come up with my number line with 0. We can put -1, though not necessary. 1, 2, 3, 4, 5, 6. And finally, 7. When you say that x is greater than or equal to 4, which could be these numbers we are referring to? These numbers could be the 4 itself. Why the 4 itself? Do you remember? Oh, sorry. Do remember, we mentioned already that when the inequality symbol is greater than or equal to, the focus is on the word or equal to. It means the inequality symbol is allowing me to consider 4 as one of the possible integral values of x. Well, that does not matter here in this case. So what do we do? At 4, I will have my dot at 4, and of course, the dot should be shaded. Then you indicate that when we say that x is greater than or equal to 4, the possible values of x could be the 4 itself, 5, 6, 7, 8, 20, 35, 48, 100, etc. So where are these numbers found? These numbers are found from 4 heading in this direction. So you'll indicate with a line that the possible values of x will start from this dot as you move in this direction. You have the option of drawing a line above the line you already have, or maybe you make the line thicker, whichever way. You can make the line thicker, or if you like, you just draw another line above that other line to indicate that these values of x are from 4 heading in this direction. And that becomes our number line. Which brings us now to the second one. What do we have in the second one? In the second one, we are having 5 minus 3x is less than negative 4. What do we do? Like I mentioned, on top of the 2 rules which I gave you, the rest of the rules in mathematics will stay. What do I mean? We will start by putting the like terms together or collecting the like terms. That should mean the 5 will cross over to the other side. So I will have negative 3x is less than negative 4. If the 5 crosses over, the 5 should become a negative. So negative 3x should be less than negative 9. Minus 4 minus 5 should give us negative 9. We will then divide this one here by negative 3 and this one here by negative 3. Do remember, we mentioned somewhere in our second rule that whenever an inequality is divided by a negative, for this thing to remain mathematically true, the symbol should now change from less than to become greater than negative 3. I hope that is taken note of. The symbol is no longer less than, but now greater than negative 3. How will this look like in a number line? In a number line, I will have negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. At negative 3, we will have a dot. Take note, this time round, our dot must not be shaded. So in fact, it is better you place the dot in this manner. When we say that x is greater than negative 3, which numbers could we be referring to? When we say that x is greater than negative 3, the possible integral values of x will be negative 2, negative 1, 0, 1, 2, and so forth. In other words, the values of x will be found on this other side of the line. Like I already mentioned, you have the option of making the line thicker or just drawing another line immediately above the line we have already, the number line. Bringing us to the last example, the third example. Please do take note, the important thing in this thing here is, be reminded that when an inequality is divided by a negative, the inequality symbol must change. Bringing us to the last example. Bringing us to the last example. We have 3 into bracket x minus 1 is greater than 4x plus 7. You are again required to solve that inequality. What will be 3 times x? That will be 3x. 3 times negative 1 should give me negative 3. you are strongly advised to start by breaking the bracket. Is greater than 4x plus 7. Like we already mentioned, we will start by putting the like terms together if there is any. That will mean the 4x will cross over to this other side, then this 3 will move to the other side. So I will have 3x. If the 4x crosses over, the 4x will become a negative. It's greater than 7. What happens when the 3 crosses over? The 3 will become a positive. I have collected the like terms. 3x minus 4x should give us negative x. And 7 plus 3 should give us 10. The inequality is not completely solved until the negative leaves. How do we do away with the negative? I'll divide this by negative 1 and this one by negative 1. Be reminded that whenever an inequality is divided by a negative, for it to remain mathematically true, this symbol has to change to become less than. So I'll be having x is less than negative 10. How will this be represented in a number line? In a number line, I will have something of this sort. Let's have negative 16, negative 14, negative 12, negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2, and 4, and 4. So what do we have? At negative 10, we will have a dot which is unshaded, like we already mentioned. When we say that x is less than negative 10, which could be these numbers we are referring to? This will be the numbers from negative 10 headed in this direction. So the possible values of x will be the numbers from negative 10 in this other direction. Those are the possible values of x, and this is how the number line would look like. Bringing us to the next subtopic, and in the next subtopic, we are going to consider simultaneous and compound inequalities. Simultaneous and compound inequalities. I want us to look at simultaneous and compound inequalities. In this one, I will give you only one example. Watch out for our next video. I'll be giving you more examples of simultaneous and compound inequalities. Let me take you through one example of simultaneous inequalities. You are asked to solve the inequalities. Solve the inequalities 2x minus 5 is greater than negative 11, and 3 plus 2x is less than or equal to 13. Giving the answer. Giving the answer as a combined inequality. Giving the answer as a combined inequality. Then in the part B, you are required to represent the solution in A above in a number line. Represent the solution in A above in a number line. One common mistake that students do is to mistake simultaneous inequalities, or the word simultaneous, to mean two unknowns. That is correct but not accurate. Why am I saying so? It is true, but it is true to say that these are simultaneous equations. That is very correct. That is very correct. Simultaneous equations are equations which come in pairs. That should be the accurate definition of simultaneous equation or inequality. So many a times, when students come across the word simultaneous, what comes into their mind are equations carrying two unknowns. That is correct, like I've said, but not accurate. Simultaneous actually means a pair of equations or inequalities, a pair of equations or inequalities. Even the word pair is not that accurate because sometimes there may be three equations given. Let's talk about that one later. Let's focus on this one here. Solve the inequalities, these ones, giving the answer as a combined inequality. How do we solve these two inequalities? Take note. I'm going to solve the two inequalities separately. 2x minus 5 is greater than negative 11. And 3 plus 2x is less than or equal to 13. Starting with this one, I'll have 2x is greater than negative 11. The 5 will cross over to the other side to become a positive 5. So 2x will be greater than negative 6. Negative 11 plus 5 should give us negative 6. Divide this by 2 and this by 2. These two should cancel out. X should be greater than negative 3. Bringing us to this one here, 2x is less than or equal to 13. What happens when the 3 crosses over? It will become a minus. So this will be 2x is less than or equal to 10. Divide by 2, divide by 2. So x will be less than or equal to 5. I have succeeded in solving the two inequalities. Do take note, the question mentioned that the answer should be given as a combined inequality, which is to mean we do not want two separate answers, but instead one answer. And that one answer is what I'm calling a compound inequality. Combining these two answers into one answer is what we call, the result we get is what we call a compound inequality. This is my advice. You may come across a question tomorrow that does not give you the instruction to give the answer as a combined inequality. Please make it a habit that when solving simultaneous inequality, whether mentioned or not, give the answer as a combined inequality. The question should be, how do we combine them? When combining these two inequalities, you will be required to start with the smaller number. What is the smaller number? Between -3 and +5, which number is smaller in this case? -3 is the smaller number. So what do we do with this? Remember, we are trying to combine the two answers. Now, in this case, we are going to make them to share one x. So the x will be written only once. So the two numbers will be sharing one x. In the process, you find yourself, you realize that you have already interchanged the two. You have already interchanged the two. But why? In an attempt to make the two numbers to share one x, you have found yourself already bringing the -3 first, then the x second. Remember our rule number 1. When these two things are interchanged, the symbol should change as well. As for this other one, you should notice that the same way it was here is the same way I have written it. So you don't have a reason to change the symbol. Now this is the combined inequality. That becomes our answer. Which now brings us to the part B. What is the part B asking? The part B is asking you to represent the solution in a number line. How do we represent this in a number line? Let's have -3. Let's have -4. Allow me to include that, though we don't need it. -3, -2, -1, 0, 1, 2, 3, 4, 5, and maybe 6. Do not take note. At -3, I will not shade my dot. Then at 5, we will shade our dot. I will have a line joining the 2 points. The x lies between those 2 points. Have a nice time. Check out on our next video. We'll be discussing more